Hi guys, welcome back to my channel Pirai Academy. In this video, we are going to see about a Leetcode question number 316. Remove duplicate letters. Given a string S, remove duplicate letters so that every letter appears only and once and only once. You must make sure your result is smallest in lexical order among all possible results. Okay. So first of all, you want to know about what is meant by lexical order, right? So if I say ABC, right, which is lesser than BAC because B is greater than this A. Okay. If I say AABC is lesser than ABBC because here A, here B. So it is like whenever the alphabets arrangements are in a smallest way, then that's going to be the lexicographically smallest. For example, another example, ADABC is greater than CABD. Can you understand this? Because here it is D, here it is C. D is greater than C. All the remaining things are lesser than these things. But the initial is greater. For that reason, it is greater than this string. Okay. Now hope you understand what is my lexico order or smallest possible lexicographical string. Okay, fine. Now see this example, S is equal to BC ABC. So you want to take the unique letters and arrange them in the lexicographically smallest in lexicographical order. Okay, so see here ABC, how I will be taking these last three things, A, B, C, that's it. Can you understand this? Okay, so I'll be remove first B and second C so that all the things will be smallest lexical order of unique letters. So see here for this I'll be taking here A, B, sorry, what is the value? ACDB. Okay, so this is the result. See here, if I delete this C and this B and I'll be make this A as it is and delete this C and this C. Now I'll be having only the unique letters and also it is the smallest possible lexical order. Can you understand this? Okay, now hope you understand how we are going to delete the duplicates in such a way that only unique letters will be in my output. Okay, as you know, this problem is quite harder than you think, right? In one single pass itself, we cannot just solve this problem. So the logic is simple after I'm just solving this problem. Okay, so the logic behind this is we want to remove the duplicates, right? So that's the main thing. So the logic behind this is, first of all, I'll be traversing among this. Okay, just understand the logic first. Okay, so first it is C. Okay, now again I'm traversing and encountered what? Encountered B. B is lesser than C. B is lesser than C. So if I add B here, okay, whether this is lexicographically smaller or B and C is lexicographically smaller. B and C is lexicographically smaller. B and C is lexicographically smaller. So for this reason, I should be first checking. I should be checking whether here it is B, right? Here is B, but in front of B there is a C. So I will be checking whether after B there is some C or not, like this. If there is some C after the B, then I can surely remove this C and add B there itself. Can you understand till now? Yes. Now I'll be going here. It is what? A. Now BA is smaller or AB is smaller. AB is a smaller thing. AB is a smaller thing, right? So what I'm going to do here is I want to check whether B is occurring right side of my A. Yes, B is occurring here. So what I'm supposed to do, I'll be just delete this B and make A here. Okay, now here comes C. Whether C is C is greater than A or lesser than A. See here, AC or CA, which is smaller? AC is smaller. AC is smaller. So in this particular case, I will be adding C as it is. Now here comes D. Now whether ACD is smaller or DAC is smaller, ACD is smaller, right? So I'll be just adding it. Come up with me. It will be much more easier when I explaining this. Okay, come up with me. So now see, okay, already I have a C. Already I have a C. Then why I again must have the C? Can you understand this? Already I have a C. Okay, all the elements should be occurring one time. Already I have a C. Then why should I again add a C? So ignore it and go to the next step. So here again B. Okay, whether A, C, D, B is smaller, or we may also take like A, B, C, D, right? We may also have like this, right? But it is smaller. It is smaller. So whether I can make this string or not. Now my entire thing is whether I can make this string or not, right? So here it is B. In right side of B, C is there. But if there is any D, then I can construct this string. But there is no D, unfortunately. So I cannot take this D. So I'll be remain like B here itself. Okay. Now again go here. It is C. C is already there. So skip. So that's it. So what is my best possible answer? It is ACDB. Now I hope you understand some logic behind it. Okay. Now we can get into the actual logic. See here. First I inserted C. Then when I'm seeing B, I deleted the C and inserted B right here. Right. So it is like I'll be going along these parts. Whenever there is some condition, I'll be rolling back to its previous values like that. So for that, what data structure should I use? I'll be using first in, last out, stack data structure. Right? Okay. Now hope you understand why we are using a stack data structure. Okay. And another thing we have done here is we have checked whether, let me change the color. We have checked whether anything is used already or not, right? Because see here, C is already here and C is occurring again. Whether I have inserted a C here, no, right? So for that reason, we want to check whether it is already used. Already we have that in our result or not. For that, I'll be taking an array of size 26, where 0 represent A, 1 represent B, and 2 represent C, and etc. so on. Now hope you understand this. Okay. Now next I want to check whether, see here how I supposed to delete this C and replace this as B. See here, first I have C. Okay. When I encountered this B, I checked whether any C's are in its right side or not, right? In its right side or not. If there exists any C, then I can delete the C and make a replace as P. For that, I again have another array of size 26, where 0 represent A, 1 represent B, and 2 represent C, where the particular index will be holding the maximum indices. See here, A means what is the last occurrence of A? It is 2, right? So here it will be 2. For B, what is the maximum? What is the last occurrence? It is 6. Okay. Now for C, what is the last occurrence? It is 7. So 7 will be here. When I encountered C and put here, and when I again encountered B, I'll be checking what is the index of B here. What is the index of B here? It is 1, right? 1. Okay. Whether I have any C in my right side, because I want to delete this C so that I can able to go with BC, right? So I want to check whether any C is in my right side or not. So I will be going here and checking whether what is the index of the last occurrence of C. It is 7. So what is the occurrence of B now? It is at 1, right? I am standing at particular index called 1. So 1 is lesser than 7. So I can surely tell that after this B, I have that C. So here I make sure to delete this C and go with B. In future, I will be taking this C. Can you understand this? So I am using 3 data structures totally. Okay. Now let us go with the actual implementation. So listen this carefully. Until now, if you cannot understand anything, now you can understand everything. Okay. So see here. Initially, what are all the data structures I am going to take? One is stack. Let us take the stack data structure. And another one is array of size 26. Okay. 0, 1, 2, 3, 4, etc. so on. Okay. Array of size 26. That's important. 26. And another array of size 26. Okay. Now this array is to represent the used, whether it is used or not. So this array will be having the latest occurrence or the last occurrence of the particular elements. Okay. Here in used, everything initially will be false. Everything initially will be false. Okay. Rest of them, these will be empty initially. Okay. Fine. Come up with me. This will be absolutely a beautiful technique. Okay. And it is also simple. It is so simple problem. Okay, if you understand these logics. So see here, first of all, I'm going to traverse. So see, first I'll be traversing the entire string and I'll be putting into the latest occurrence. Okay, initially the latest occurrence, everything you may take them as -1 also, but my opinion is don't initialize any values to the latest occurrence, because the compiler itself give the default value or the garbage value based on your programming language. Let be that itself. Okay, just understand this. Now C is occurred. Okay, and what is the index of C? It is 0. It is 0. So the latest occurrence of C is 0. So C means where? See here A, B, C, D and E, etc. so on. So C means here. So here I will be replacing as 0. Hope you understand this. Now B's latest occurrence is 1. So go to B and initialize as 1. Now A's occurrence is 2. So go to A, which means 0th index, and make this as 2. Okay. Again it is C. C is occurring at 3. So here I will be update this as 3 because 3 is the latest occurrence or the last occurrence as of now. Okay. Now D is what? 4. So go to D, the third index, and make this as 4. 4 means 4 is the last occurrence or the last index where D is occurred at right of now. Okay. Now C is 5. Again make this as 5. Okay. Now B is what? 6. So make this 6. And again C 7. So make this, let me erase this so that it will be not clumsy. So instead of these things, okay, make this as 7. That's it. Now my latest array is ready. Now it's time to again traverse this string. Okay, now listen this carefully. Again traversing this. So I'll be here C. Okay, now whether I want to add this C in my result or not. Yes, you will add because the stack is empty. So let me write down the conditions here. So first condition is stack is empty. Stack is empty. Okay, so I'll be adding the C directly into the stack. Let me change the color so that it will be more easy for you to understand. So C. Okay, now I'll be going to the next thing. Next thing is what? B. Okay, B. Okay, now check whether my stack this value, the stack top value is greater than the current value. Yes, it is greater, which means it occurring like CB, but I don't want a CB, I want BC, right? For that reason I will be go and check. I will go and check whether my C is 7, right? But B's index is what? 1. So which means I am sure that after this B, C is definitely occurring. C is definitely occurring. At that particular point, I will be adding that C. As of now, I will be don't add C. Okay, and also I forgot to say, whenever I am adding the C here, I will be making the C's particular index to true. Okay, can you understand this? Fine. Okay, now come to this part. Now B, whether I want to add this B here or I want to pop this C right now. Okay, I want to pop this C because C is occurring after B at this point, right? So I will definitely just pop out C and I'll be adding this B because the stack is empty. So what is the second condition I have mentioned? So if stack's top element is greater than the current element, okay, then what should I do? I will go and pop it out. Okay, before that, what should I do? The condition and also the latest of the top is greater than the current index. So if these three conditions, sorry, here it is not empty. If the stack is not empty and stack top is greater than the current and also latest top, okay, latest of top is greater than the current in this, then I can immediately pop out the top value. Okay, whenever these conditions are true, I will be repeatedly popping out the top value. Fine. Okay, okay. Now come up with me. Now again, I will be going here. It will be A. Okay. So hats off now. The C will be again turned into false because we are just popped out this C, right? So the C will be just made as a false and this B will be made as true because we have successfully inserted B, right? Now A. Now A. So A, whether the stack is empty, no. Whether my A is lesser than the B, yes. So this condition is also true. Okay, okay. Now what is the next condition? Latest of top. So what is the B's in this? So it is 6, right? It is 6. Whether the 6 is greater than the current in this 2. Yes, it is greater. Then what should I do? What should I do? I will be just popping this B out and making my B as false because I didn't use the B, right? So again I will be making this B as false. Okay. Now whether my stack is not empty, no, it is empty. So I will be adding the A into the stack. Up to this, hope you understand this. Okay. Now let me just erase this and write the value. So see here it will be true, here it will be false, here also it will be false. Hats off now, right? Okay, now go to the next in this. So it is what? C. Okay, whether C is in the used, C is true in the used, no, it is false. It is false, which means we can go and do these operations. We can go and do these operations. Okay, check whether stack is not empty. Yes, stack is not empty because it contains A. Whether stack top is greater than the current, no, no. So this condition is not satisfied. So directly I can say you will be adding the C in front of the A. Can you understand this? Okay. Now go to the next in this. So D. So before going to the next in this D, I will be making this C as true. Can you understand this? Yes. Now D. Okay. Okay. Whether D is used already, no, it is false. So which means we want to use now. Okay. Whether the stack is not empty, yes. Whether the stack top is greater than the current element, this D, no. C is not greater than D. So this is not true. So I'll be just adding this D to the stack. Okay. Again, it is what? C. But so before going to the C, D is added, right? So I'll be making this as true. I forgot always to add these things. Okay. So go here. So C. Okay, whether C is used already. Yes, yes, it is used already. So don't do anything, just skip it and go to the next thing. So B. Okay, okay. B is not added till now. B is not added till now. So go to here. Whether stack is not empty. Yes. Whether stack top is greater than the current element. So D is greater than B. Okay, it also true. So come here, latest of top is greater than the current element. Okay, top is D. Okay, so D's latest or D's last occurrence is what? 4. Whether 4 is greater than 6? No, no. So this condition is false. So such a way I cannot just pop the D. Instead, I will be just appending this B top. Sorry, I just pushing this B into the stack and making this as true. Okay, now go to the next in this. So it is C. Okay, whether C can be inserted? No, no, because C is already used. Because the used array denoting what? Hey, C is already used. That's the reason why the C is true. Okay, so I cannot use the C. Okay, now what are all the elements in the stack? So these are the answers: A, C, D, B. Okay, and also I forgot to tell you why we are taking the size of these two arrays as 26. Because there are 26 alphabets. Okay, and in this array 0 represent A, 1 represent B, 2 represent C, and 3 represent D, etc. so on up to 25 represent Z. Can you understand this? So for this particular reason only I am taking these two arrays as 26 size, and in code, I'll be showing you how we are just getting into these indices and just updating the values. Okay, fine. Now tell me, what is the time complexity? This is going to be a tricky one, right? So what is the time complexity? I can tell you the time complexity will be O of n. Yes, because we are only traversing throughout the entire string. Okay, apart from that, we didn't doing anything apart from that, right? We are just popping and pushing into the stack, which will be a constant time. Yes, and we are just accessing some elements from the array, which also going to be just constant time. Yes. Okay, what is the space complexity? First of all, I'm taking the stack, so it will be O of n plus I'm taking two arrays of size 26, which means 26 plus 26, and constant will be cancelled out, so space complexity will be O of n. So time and space complexity is O of n. So this is the optimized approach and the only approach for this problem. You may also try any other approaches, but this is the optimized approach. Okay, so let us see the code. When seeing this code, you can understand this clearly. I am taking the Java code. If you want the Python or C++ code, you may get in the description. So see here. First of all, I am taking the length of the string and storing in n, and I'll be taking the last index array as size of 26 to store all the elements last index occurrence. Okay, the last occurrence of the all the unique alphabets. Okay. Now boolean of used is equal to the 26 size. Okay, so this will be representing whether I used this particular alphabet in my result or not, if it is there at this particular time or not. For that reason, I have used this variable. Fine. Now I'm using a stack data structure for just doing the operations. Fine. Now first of all, I'll be taking all the elements. I'll be traversing that entire string, and I'll be taking all the elements and storing its latest index into the this last index array. So see here, last index of s dot character of I, which means if there is a character, if I am traversing and I encounter C, for example, C minus A. So what is the ASCII value of C? It will be like 97, 98, 99, right? 99. Now A will be 97, so 99 minus 97, which is equal to 2. So at the particular index 2, I will be just initializing as I. Okay, so like in the drawing explanation, it will be updated again and again, and we got the last index array where all the index represent where its corresponding character is occurred at last in the given string. Okay, fine. Now again I'll be traversing the whole string, and I'll be taking the each and every character, and I'll be checking whether that character is used or not in our resultant. If it is used, I'll be continuing it. I will skip that iteration, right? For that I'll be using the continue. Else, what are the conditions I need to check? The first condition is the stack should not be empty. Okay, and the stack, the top element should be greater than the current character, and also the last index of the stack top element is greater than the current index. If these three conditions are satisfied, then only I will be popping the top value from the stack, and taking that particular value, I will be just making the used arrays that particular value as false. If I pop the top value where top value is equal to B, then I will be going to the used array and making that particular index B, which means index 1, as false. Because I just deleted the B from my result, which means I want to just make the first index of the used array as false, such that it telling that B is not used in the result now. Can I understand this? Now come here. After doing this, I will be just adding the current character into the stack. Okay, and make the used of that current character is equal to true. Fine. Now I am using a string builder result, and I will be just concatenating, or I just appending the single character from the stack. That's it. And at last I will be returning by using the toString method, because they are asking to return us in a string data type. Fine. So this is the entire code. So let me submit this. Yes, it is submitted successfully. To know about these kinds of algorithms, just go and search in my YouTube channel. And if you really like this video and subscribe to my channel. And I know understanding this problem is pretty much difficult, but still, if you really understand this, or if you have any other doubts, just comment below and give some suggestion about this video. Thank you.